This is our first lesson of Chapter 6, and it roughly corresponds with Section 6.1 in your textbook, looking at the area between curves. So before we start talking about the area between curves, I want to review how to find the area under a curve. So we're going to start with this example. We're going to find the area under the curve of y equals 6x from x equals 2 to x equals 5. So just to review, we need to take an integral from x equals 2 to x equals 5 of 6x dx. So I want you to pause the video and try to attempt this, or just attempt this problem. And then when you unpause the video, I will skip ahead to the worked out answer. So we do the reverse power rule on 6x, right? Remember, this is 6x to the first power. So if we do our reverse power rule, we're going to add 1 to the exponent, so it's going to be x squared. And then we have to divide by our new exponent, 2, which gives us 3x squared. And then our fundamental theorem of calculus says we're going to evaluate this from 2 to 5. So then we plug in 5 and we plug in 2. 3 times 5 squared minus 3 times 2 squared. And then that gives us 75 minus 12, which is 63. So the area under y equals 6x from 2 to 5 is 63. Let's try another one. Find the area under the curve of y equals 6x squared from x equals 1 to x equals 3. Again, please pause the video and attempt this by yourself. And then when you unpause, you will be able to see the fully worked out answer. Here it is. So recall reverse power rule. Okay, we have 6x squared. Again, we're going to add 1 to that exponent when we integrate. So we get x cubed, and then we divide by that new exponent, and that gives us 2x cubed. So we're going to take our 2x cubed and evaluate it from 1 to 3. So we have 2 times 3 cubed minus 2 times 1 cubed. 3 cubed is 27. So we have 2 times 27 is 54. Minus 2 is 52. Here's our geometric representation, or just our graphical representation. So we have the graph of 6x squared, and the area under the graph from 1 to 3 is going to be 52 square units. Okay, last example for finding the area under the curve. We're going to find the area under sine of x from x equals 0 to x equals pi. Last time, pause the video, and when you are ready to check, you can unpause and it will skip ahead to the worked out answer. So the integral of sine of x is negative cosine x. Good to remember our little cycle here. So we have sine x. The derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of negative sine x is negative cosine x. And then the derivative of negative cosine x is sine x. So that's our derivatives, right? This is our derivative.